What's up there, geometry? Longo here, about to show you how to do some ratio application problems. So what we're going to be doing here is focusing more on the word problems, some application of what ratios and proportions can be used for solving missing information. So the first example we have here is Joey is practicing his free throws. Maybe he's got a basketball game coming up or something like that, and he just made 12 out of 20. So if he continues making free throws at that exact same rate, how many will he make if he shoots 50 times? And another question is, how many shots will he need to take before he makes 72 free throws? So to do that, I always like to set up a little word ratio is what I like to call it, and we're just going to call this the number shots that he makes over the number of shots that he takes. Now when you're solving ratio and application or proportion problems, you want to try to make sure that you keep a very consistent ratio. So we know that he makes 12 out of 20. If you want to make your numbers a little bit easier, you can always reduce this. Basically, he makes 3 out of every 5 free throws. Now, you don't have to do that. It'll just make your numbers a little bit smaller and easier to manage. Okay, so he makes 3 for every 5. So how many will he make if he takes 50? Well, to do that, we're just going to call our unknown x, and then you just have to cross multiply. So 5 times x is 5x is equal to 3 times 50, which is 150. Divide both sides by 5, and you end up with him making 30 free throws. Okay? So really it's just taking a ratio, setting up two ratios, cross-multiplying, and you find out that he needs to take 50 shots and he'll make 30 if he continues at that rate. So part 2 of this question said, how many shots would he need to take if he wanted to make 72? So now how many we take is the unknown. We still have the same ratio, 3 over 5. But this time we're going to say he's going to make 72. How many does he need to take before that will happen if he continues at the same rate? And then you would just cross multiply again. And you would have 3x is equal to 360. Divide both sides by 3, and he needs to take 120 shots. All right, so that's an example of how you apply ratios to a word problem. Now what we're going to do is we're going to work with an extended ratio. So right here we have the perimeter of a triangle is 39 inches. And the ratio of side lengths is 3 to 4 to 6. So we have 3 parts now. That's why it's called an extended ratio. And we want to find the measure of each side. So the first thing we probably want to do here is draw a triangle. Since the lengths are unknown, instead of calling them 3 inches, 4 inches, 6 inches, we're actually going to say that that's 3x, 4x, and 6x. Because what we're going to need to do is find x to determine what's going to give us a perimeter of 39. Okay, so now that we know that the perimeter is 39 and we have our ratio, this just turns into an algebra problem. So we have 3x plus 4x plus 6x is equal to 39 inches. Combine our like terms and we have 13x is equal to 39, which means x is equal to 3. So our scale is 3. So that means the length of this side is 9, the length of this side is 18, and the length of this side is 12. And of course, you can double check your work by saying 12 plus 18 is 30 plus 9 is 39, so it checks out. Okay, so what we did is we took a ratio of sides, applied it to a perimeter, and we found the missing scale to determine what the length of all 3 sides are. Okay, so you can see that that is a ratio of 3 to 4 to 6, and you're good to go. So there's one more. I'm just going to let you try this one on your own. So when you're ready, pause the video, give it a try. When you're ready to see the answer, click play again. So the blueprint of a house uses 2 inches represents 5 feet scale. What are the actual dimensions of the bedroom below? So this bedroom on a blueprint has 4-inch by 5-inch dimensions. If the scale is 2 inches represents 5 feet, then what are the actual dimensions of this bedroom? Go ahead, press pause, try it on your own. As soon as you're ready, click play. Give it a shot. If you found that the dimensions of this bedroom are 10 feet by 12.5 feet, you are correct. To do that, you just had to take the given scale, set it up twice. 2 inches over 5 feet is equal to 2 inches over 5 feet. And then for each wall, you would have to put 4 inches over how many feet and 5 inches over how many feet. And from there, all you had to do is cross multiply and solve, and you would find out that the walls are 10 feet and 12.5 feet. Alright, so that's it for this video on ratio applications. This is Longo and I'm out. See you, bye.